Hello there. As you can see, I have a rubber band in my hand. Now the moment I stretch the rubber band, the length would increase. But at the same time, the rubber band would become thinner as well. Now we define a ratio called Poisson's ratio. Now this ratio is a material property that measures how much a material becomes thinner in one direction when it is stretched in another. Like in our case, we were stretching the rubber band in this direction and the rubber band along with getting stretched was getting thinner in this particular direction. So now let's understand Poisson's ratio a little more in detail. So when a wire is loaded, its length increases while the diameter decreases. The strain produced in the direction of the applied force is called the longitudinal strain, and the strain produced in the direction perpendicular to the applied force is called the lateral strain. So you might be familiar with the word strain. So strain is actually change in dimension divided by original dimension. Mathematically, Poisson's ratio can be defined as within the elastic limit, it is the ratio of the lateral strain to the longitudinal strain, and that is what is called the Poisson's ratio. Let's derive a formula for Poisson's ratio. Now let's assume that there is this wire that is loaded, and the moment you load this wire, the length would increase. So let's say the initial length of the wire was L, and once you load this wire, the length increases by delta L. So the new length is L plus delta L. Also, let's say the diameter when the wire was not loaded is D, and let's say the diameter when the wire is loaded now becomes D minus delta D. Now Poisson's ratio is represented by sigma, and that is equal to lateral strain divided by longitudinal strain. In the lateral side, the dimension that is getting changed is this delta D. So I can say that the change in dimension is negative of delta D. The negative sign denotes that the diameter is shrinking, it is reducing, and the initial diameter was D. And in the longitudinal side, the dimension that is getting changed is the length. So I can say the change in the dimension would be delta L, and the original dimension was length L. So I can write sigma as negative of delta D divided by D divided by delta L divided by L. So this becomes negative of L divided by D times delta D divided by delta L. Now this is the formula for the Poisson's ratio, and the negative sign in this formula is telling us that as the length is increasing, the diameter is decreasing. Now let's also identify the SI units of this Poisson's ratio. Now if you see here, everything is a unit of length. So the final unit or the final SI unit for the Poisson's ratio will come out to be unitless. So we can say that the Poisson's ratio does not have any unit and any dimension. So I hope you are now familiar with what is Poisson's ratio. See you in the next video. Till then, bye bye.